Hi, I'm Kristin Tippey. I'm going to talk a little about hierarchical data files analysis of mass spec. So, as with any SIMS data, there's a few necessary steps. You have to be able to plot intensity versus mass to charge ratio. You have to be able to analyze which regions are interesting and tell the difference between them. To pick out species of interest, say oxygen or hydrocarbons, and cross-correlate all these areas with possible environmental factors like electrical bias. So the main end goal is to prepare and plot the data so that people can understand it and potentially be able to recreate it or use it in the next steps. So for data processing, we had to read in the hierarchical data file into MATLAB matrices. I picked X for mass calibration header and Y for the SIMS data header. I plotted an example data point, X equals 100, Y equals 100, and picked out some of the species of interest. The lithium peak, the niobium peak, and the niobium oxide peaks were the largest peaks, and so I used them to start this analysis to get an idea of what I was looking at. And Mesh C creates a mesh with a contour background, so you can get a more 3D visual of what's going on. So here's the species of interest, their mass to charge ratios, and what that corresponds to in the Y array, which you'll recall was from SIMS data. So a few things that you can notice is I replotted the mesh versus contours for lithium, niobium, and the oxides. Now lithium has low points, where niobium oxides have high points. This makes sense when we take into account that this lithium is most likely actually a lithium hydride, as I miscalibrated the earlier data. And oxidation and reduction kind of should have opposing reactions, which goes along with the whole electrical bias thing, which is as far as I understand this material. I went back and recalibrated based on the niobium peaks weren't where I expected them, assuming that the biggest peak was the lithium peak. Again, this is lithium hydride most likely. The low points and the high points are still reflective of high oxygen and high hydrogen species. So this was my first attempt at saying, okay, this happens in these areas, but I was like, we need more data. I tried to plot them out individually, these different species at 14, 15, 16, but it was still kind of messy and hard to say what we were seeing. I tried 2D visualizations, it was starting to get better. And then I thought, okay, let's try some line profiles. I did lines across these data points, and it's really messy across the X's, across the Y's, but if we start to smooth them, we start to see something, and if we add together the smooth peaks, we really start to see things. So here you'll see, like, we have some preferential partitioning away from whatever these boundaries are, and definite peaks and valleys. I turned this whole 2D distribution map into line profile technique for all of the species that I identified as being significant peaks in the data. And I did lineouts for all of these main species. Now, like I said earlier, my initial thoughts of what was lithium and what was lithium hydride may have been mixed up. So initially, I gave lithium the high peak because it was the biggest peak in the 7 area, and I expected it to be lithium. But seeing that there's a big peak at 6.4 and a big peak at 7.4, it makes more sense that we have a lithium and a lithium hydride. So that's what I'm thinking is going on now. They have opposite responses, which would make sense if it's a polarity-induced type difference. Niobium, you wouldn't expect much of a difference across the profile because there isn't anything. Niobium oxide, we start to see peaks and valleys, and niobium dioxide increased contrast between these. So I did this for the rest of the species of interest and found peaks in the hydrocarbons and the oxygen-containing species, especially this lithium oxide type thing, and some hydrocarbon or nitride that is resultant from probably the making of this material. At this point, I would take the data and talk to the experimenters and see what they think is actually the most interesting features to follow up with. That's what I have.